Okay, we've got kind of an easy lesson today. We started logarithms the last time we were together. Introduced logarithms. A logarithm is simply an exponent. Today we're going to get into some of the harder parts of logarithms because we're going to work with the logarithm rules. There are three primary logarithm laws or rules, whatever you want to say. You can use these rules to solve equations. We're going to use these rules when we get into some applied problems dealing with exponential growth or exponential decay. So they're very, very important. And let's get to it. All right, so here are the log laws. This is the way I think you ought to remember them. I can give you, like for instance, over here is the actual rule itself. But it makes much more sense for you to remember the log of a product is the sum of the logs, okay? The log of the product is the sum of the logs. Now, I want to demonstrate why this is true to you, but when you think about what logarithms are exponents. They're exponents. Product is when you multiply. When you multiply x to the 7 times x to the 4th, what do you do with the exponents? You add them and get x to the 11th. So the exponent of a product is when you add the two exponents together, and that should make sense to you. Now, demonstration as to why that works. These are common logs. It works with any log of any base, okay, but I just made it common logs. It's easier to write, pardon me. But so let me give you a demonstration here. How about the log of 100 times 1,000? Okay? Now we know 100 times 1,000 is 100,000. 100,000 is 10 to the 5th power. So what do you raise 10 to get 100,000? This has got to be 5. Okay? Well, what's the log of 100? What do you raise 10 to get 100? Is it not 2? What's the log of 1,000? What do you raise 10 to get 1,000? Is it not 3? And isn't 2 plus 3 equal 5? So the log, when you're multiplying two things together, the log of a product is simply the sum of the logs. Okay? How about the log of a quotient? What do you do when you have something like this? Quotient means divide. Can't you kill 3 x's on the top and the bottom? And you end up subtracting 5 minus 3, right? Right? So the log of a quotient, the exponent of a division problem, is the difference when you subtract the two logs. Okay, how about a demonstration of that? Let's say the log of 1,000 divided by 100. Now we know 1,000 divided by 100 is 10. Okay, what do you raise 10 to get 10? Is it not 1? Okay, but what is the log of 1,000? What do you raise 10 to get 1,000? It's 3. The log of 100. What do you raise 10 to get 100? Isn't it 2? And isn't 3 minus 2, 1? Okay, so a demonstration of rule 2. But when you have division, it is the log of the top minus the log of the bottom. You simply subtract the logs. Okay, how about the log of a power? The log of a power is the power times the log. This is the one right here that you will use more than any of these three rules when we get into the application problems with logarithms. And think about what you do when you have a power raised to a power. Like if you have x cubed raised to the 5th, don't you end up multiplying, right? Multiplying. So the log of a power is the power times the log here, which is an exponent. Okay? So it's the powers times the log. So log of a power, you can bring this b down, and it's just b times that. How about a demonstration? The log let's say, how about 100 cubed? Okay? What is 100 cubed? 100 times 100 is 10,000 times 100 is 1,000,000. Yeah, okay? So this is 1,000,000. What do you raise 10 to get 1,000,000? 1,000,000 has 6 zeros, so you must raise 10 to the 6th to get 1,000,000. Now, this rule says that the 3 can multiply times the log. 3 times the log of 100. And the log of 100, what do you raise 10 to get 100? Is it not 2? And isn't 3 times 2? 6. Okay? So there are your log rules. So let's talk about, can you expand these 4 problems just simply using log rules? The first one, log to the base 2, 6 times x. That's a product. We're going to use rule 1. The log of a product is the sum of the individual logs. This would be equal to the log to the base 2 of 6, the log to the base 2 of x. Okay? Just add them. How about this one? The log to the base 5 of x cubed y to the 6. That is a product. So product, this could be the log to the base 5 of x cubed plus rule 1, the log to the base 5 of y to the 6th. Ah, I'm done. I did it. Ah, but aren't these each powers? And the log of a power is the power times the log. You can bring the power down. So the 3 comes down. 3 times the log of x. Bring the 6 down. 6 times the log of y. Okay? All right. Natural logs just have a base of e, if you recall. Okay, nothing different. All the rules still work. All right, so let's try it. Natural log of AB over root C. Out of all 3 rules, the first one you have to be aware of is the quotient. This is a division problem, top divided by bottom. Now there's other stuff we're going to do, but it's division to get you started right away. All right, so the log of a quotient, when you're dividing, I can subtract these 2. So it's the log of the top minus the log of the bottom, right? And then this is the log of a product, rule 1. So I can add ln A, ln B. This, if you remember, square root is a fractional exponent. Isn't this the same as c to the 1/2, which is a log of a power, rule 3. I can bring the 1/2 down, ln of c. Okay? Last one, natural log. Now, a root is a power of 1/2. So the overriding thing we're going to start with here is the log of a power. I can bring this power down. This is 1/2. Now look what I have. I have 20x squared. So it's the natural log of 20x squared, which is a product. So I'm going to break that up into 20 plus rule 1, the natural log of x squared. Okay, I brought the 1/2 down, and I added those 2. Okay, I got one more thing to do. You could find the natural log of 20 with a calculator and take half of it if you wanted to. I'm going to write 1/2 natural log of 20. I can bring this power down, rule 3. So it's 2 times natural log of x. Can we all see that clearly? It's a little faint. I'm going to have to write a little bit darker. Okay? Okay, down here at the bottom. Now we're doing the exact opposite. Here we broke it down into all its parts. We expanded. Here, we want to put it all back together. It's going to be the opposite. We're going to get a smaller answer, okay, by using the log rules. This looks like rule 3. It looks like we brought the power down in each case, right? So I can take the powers back up. I can get the log of x cubed, the log of y to the 1/2. Yes? And then that's a sum. That's a sum. I'm adding, so it should be rule 1. I can end up multiplying these. Log of x cubed, y to the 1/2. Or you could make it square root of y if you wanted to. How about this one? Let's do the same thing. Let's take the 3 up, the 1/2 up, the 2 up. So I'm going to have ln of a cubed, ln, I'm going to make it root b because it's b to the 1/2, which is a square root, minus ln, take the 2 up, c squared. Is that any better? Can you folks see that better? That looks a little bit better. Okay? Now, I'm adding these two, so you know that's rule 1, a product, and I'm subtracting this one, so you know that's division. So I have the ln, the product, a cubed root b divided by c squared. Okay? Oh, these are fun. Last one, here's the only power we can take up. This is addition, which sounds like rule 1, so I can multiply this. So I get the natural log of a plus b times a minus b. All right? Minus, take the power up, log c squared. Now, when I'm subtracting, it's the same as a rule 2, that's a quotient. So it should be a plus b times a minus b is a squared minus b squared divided by c squared. Yeah? Okay? Using the log rules. Okay? Okay, how about some other problems? And we will be using log rules. How about if we want to solve for the letter A here? Okay, so I have the log of A is equal to, now, I can take this power up, take the k up, c to the k, and then it's addition. That's a rule 1. So I can make it the log. This is going to be a b and a c to the k. When it's addition, that means you multiply b times c to the k. Did you catch that? Okay? All right. Well, if the log of this equals the log of that, if the logarithms are the same, the powers are the same for 10 to get a and 10 to get this are the same, then these two things have to be the same. And a has to be b c to the k. And I've solved for a. All right? How about this one? This is kind of a cool process here. If I learn something and get a P0 on a test after T months, I would get a value of P on a second test on that same material. Then this formula is true, okay? And what this says, we all tend to forget things. So the formula is going to be able to tell you what you're going to get a certain number of months later after you've forgotten some of it. Of course, I understand nobody ever forgets any pre-calculus. I understand that. So what we want to do, we get P0 on the first test when it's real fresh in our minds. What would we get 2 months later, okay? If I got a 90% the first time, what would I get 2 months later? And the C is a constant, is the relative difficulty of the assignment. All right, so let's do it. So we have we have that the log of p, and that's what I want to find, p, is equal to the log of 90, okay, minus c, which is 0.2, times the log of t plus 1 should be the log of 3. Now take a second and check through that and make sure you're with me. P is what I'm trying to find, the score I'll get on a test 2 months later. Log of P naught is the log of 90. C is 0.2, and 2 plus 1 is 3. Okay? You can actually just work this out with a calculator. Okay, I'm going to fool around with it just for some fun here. When you subtract two logs, isn't that rule 2, the log of the quotient? And doesn't this power go up? Okay, did everybody catch that? This power goes up. Then you have subtraction is the log of the quotient should be 90 divided by 3 to the 0.2 power. Okay, everybody with me? All right, so I have 90 divided by, and I need the log of that. Now, if the log of P, oh, pardon me, if the log of P is equal to the log of that, if the two logs are the same, these two numbers have to be the same. So I know that P is 90 divided by 3 to the 0.2 power. And what is that? 90 divided by 3 raised to the 0.2, and I get P after 2 months, you're going to get a 72%. If you got a 90% the first time, you will have forgotten some, and you get a 72%. Now, remember back up here, I said you could do it strictly with a calculator. The log of 90 minus 0.2 times the log of 3 is 1.86. So if I do this with a calculator, I get the log of P is equal to 1.86. So what is 10 raised, because the log is an exponent, 10 to the 1.86, and I get about 72%. Exactly the same answer. Okay? All right. Now, here and here, some great problems in calculus. And you can use the logarithm rules to solve these. All right? Like, for instance, I told you there was no button on your calculator that'll tell you what is the log of 87 to the base 4. And that's correct. There is no button on your calculator that will tell you that. But there's a beautiful way you can do this problem. Okay? A beautiful, simple, easy way. Because a log is an exponent, and doesn't this say 4 to the x power is equal to 87? 4 to the x equals 87, yeah? Okay? And now that's a power. Wouldn't it be so easy if that x was not a power? If I could bring the x down. And you can take the x down if it's the log of that. So I'm going to take the log of both sides. All right? And then I'll be able to bring the x down, rule 3. Now, I always do it with natural logs, just because I love calculus and use natural logs in calculus all the time. You can use regular base 10 logs if you want. You'll get exactly the same answer. But I'm going to take the natural log of both sides, right? Then I can bring this power down. X ln 4 equals ln 87. And now it is simply a calculation. Just take the natural log of 87 equals divided by the natural log of 4 equals, and I get that x is 3.22. And think about it. What do you raise 4 to get 87? 4 times 4 is 16 times 4 is 64. So 4 cubed is not enough. It's got to be a little bit more than a cube. It's 3.22. Isn't that cool? You can use log rules to solve very complicated looking power functions. Let's do the next one. 5 to some power is 108.5. Well, think about it. 5 times 5 is 25. 25 times 5 is 125. So 125 is too big. So my answer should be a little less than 3, right? So I have 5 to the x equals 108.5. It would be so easy if that x was not a power. How can I bring it down? Take the log of both sides. Now this time I'll use common logs, base 10, just to show you it's going to work either way. So I'm going to take the log of this side and the log of this side to the base 10. Power down, x log 5 equals log 108.5, right? And now, just solve the problem. Use your regular log button, LOG. LOG of 108.5 equals, divided by, LOG of 5 equals x is 2.91. And didn't we say it's got to be just a little bit less than 3, right? And if you want to check it, see if it works, take 5 and raise it to the 2.91 power. Boom. And it's very, very close to 108.5, 108.14, okay? Oh, yes. Log problems. I think they're a lot of fun. If you can master just a couple of quick rules, they're not that difficult. There is your homework. Some problems from compounding interest we did at the beginning of chapter 4. This is a chapter 3 problem. I keep reminding you that I want you to remember we're having a final coming up soon, so I try to keep adding some problems for you. So good luck on the homework.